Now, as if you haven't learned so much already, well, we might as well learn you something else. Sometimes you have to use your inverse functions, and the reason you would do that is if your solutions that you find are not actually on your circle. So if they're not on your circle, then what you're going to have to do is you're going to have to just write your answers in terms of arcsine, arccosine, or arctangent. So if they're not on unit circle, so that means you need to know your unit circle, which you should already. So if your answer is not like a -1, a 0, a 1, 1/2, radical 3 over 2, or radical 2 over 2, if it's none of those, then you leave your answers in terms of arcsine or arccosine. So let's solve this equation we have here for number 9. We're going to subtract the 6 over, so we're going to have a 4 tangent squared x plus 5 tangent of x minus 6 equals 0. You always have to set it equals 0 first. And since this is very similar to the equation 4u squared plus 5u minus 6, then what you can do is you can solve this, or you can factor this as a 4u minus 3 and a u plus 2. So if we were to sub in for our u's just tangents, then once you factor this on the left, you're going to get a 4 tangent of x minus 3, and then a tangent of x plus 2 equals 0. So if we solve each of these equations, 4 tangent x minus 3 equals 0, and our tangent x plus 2 equals 0. If we solve each of these, well, we add 3 to both sides, and then we're going to divide by 4. So we're going to say we have the tangent of x equals a 3/4, which that's not on our circle. And then we also have the tangent of x equals a -2. That's not on our circle. However, these functions these values for tangent, since tangent, your domain can be all real numbers, these can both work as an answer. To solve for x, whenever you have to solve for x, you just take the arctangent, or tangent to the -1, same thing. Just two different ways to write the same thing. So then you can take, or write your answer at the very end as the x is equal to your arctangent, or tangent to the -1, of 3/4 plus, and over here you have x is equal to the arctangent of -2. Those are your two solutions. And you do this, remember, you only do this whenever your values are not on your circle. You just leave them in terms of arc, sine, arc, cosine, arctangent. Now remember, if these were arc sines or cosines, 3/4 is between -1 and 1, but -2, this would be an extraneous solution because remember, your cosine and your sines are only between -1 and 2, so -2 would not work. So now, a little reminder, something to think about, is since you have, actually I didn't finish the problem here, so let me get rid of this. This is not really our answer. I forgot to add something. This doesn't say what interval we're on. So what we need to do is we need to add like a 2 pi. Well, since tangent has a period of pi, then what you're really going to do is you're really going to be adding multiples of pi to obtain your answer. So if we're going to write down the arctangent of 3/4 plus n pi, and x is equal to the arctangent of -2 plus n pi. That's your actual answer. So I apologize, I did forget to put in the n pi's. Now the reason we're not using a 2n pi is because your period for sines and cosines is 2, but however your periods for tangent is only a pi. So that is how you solve using inverse functions.